girl, the underscore crypto gal on Twitter, and on Instagram it's just crypto gal, right?
Yes.
Okay. All right, cool. So
Wow.
I'm ready to go. Oh, I got a feedback. I had to mute that. Okay, cool. So look in here. Can you guys hear yourselves? I'm not sure. Double check. Can you guys talk real quick one more time?
I can
What's
hear
up?
myself on YouTube,
Great.
Twitch,
We're live.
Cool.
peppermint oil.
All right. Yeah, the audio thing's a little funny because I don't have an actual mixer set up yet, so we're gonna have to.
All good.
Yeah, we're gonna
Yeah,
have
it's
to.
all good. You guys mess with peppermint oil because that's like my new thing.
No. What's
Wow.
that?
Peppermint in the
Something- a
oil
mixer?
form.
Yeah.
Oh.
It's amazing.
Yeah.
Mm.
So, okay. So, Eric, what are we going to be doing today? Building a blockchain on Ruby? Is that the summation of where we're going?
Yeah, I think
What's
what I've
coming?
been doing is my own personal project to learn how to write a blockchain in multiple different languages just because I'm a nerd and I think that's cool. I was like, what should we do on a live stream? I was like, okay. I feel that a lot of people have a lot of different backgrounds when it comes to coding, like Python, Ruby, C++, Go, JavaScript, and I think it's important to introduce those concepts and just, where do you come from? You come from, like, you do a lot of JavaScript, right?
Me?
Yeah.
Yeah, mostly Angular. I wasn't doing a lot of development in Angular. Was focusing in on WordPress and PHP for quite a minute there. But with
I should do one in PHP too.
Maybe no.
Said, don't encourage them.
Yeah, dude, PHP is on its way out, man. It's not
It is on its way out, but there are some cool Web3 libraries that I was looking at, just in case you wanted to like prolong this sadomasochist relationship between you and PHP. Who knows?
Yeah, it's okay. I mean, PHP is okay. It does things. It does things and they work. And
PHP is okay if you like saxophones.
Guys, why don't we do one in Fortran?
Fortran?
You know what? Let's do it. Honestly, I will.
Try.
Yeah, definitely. Fortran would be that'd be an interesting
It would be.
I've
prospect.
never even seen Fortran.
Let's learn.
Fortran's
Yeah, so
still a thing, like a big thing.
I know. Yeah, people still program in it.
Yeah,
Well, I think this is now like what MATLAB is. MATLAB's just like a bunch of wrapped Fortran.
yeah.
It's like some 40-year-old dad code just in a big snowball of APIs.
Yeah, it works. It does good for a lot of things. It's useful.
Foundation.
PHP's never.
MATLAB's pretty dank. It's just big.
PHP's never gonna die either. Like I hope it does, but not really. I guess. Like
I doubt it will.
Yeah.
Not anytime soon.
Yeah, that's because most of the internet is running on it.
Yeah.
Definitely not going anywhere.
yeah. So
I met a WordPress dev in real life, and I was like, "Wow, you're a WordPress dev? Like you make
What?
WordPress?" Yeah, he was at Drexel. He was kind of like a hotshot. I was like, "This guy's a hotshot?"
Well, I didn't know that was the thing. That's cool.
yeah.
Yeah. He was like giving a talk on it. I was like, "Wow, I guess." No, it wasn't Drexel. It was over at Penn. I was like, "Wow, I guess this is still relevant. Should I become a WordPress developer?"
By the way, shout out IOST for this free hoodie.
Ost.
Ost.
When I
iOS
saw Ost,
token.
I thought it was like a potato chip company.
What?
Really?
Like IOST chips.
What are you talking about?
Honestly. Hey, can we add clickable links into our lives?
It's a little difficult for me to do that. I'm gonna have to figure it out.
saying.
Yeah, it'd be pretty cool if we can do a post. We can do like annotations and stuff and put links to different things. But I think you actually like YouTube.
We actually need people to look at us before we do that.
We need to
Alright.
we need to start doing like D Live, DTube, because like they don't care what you do, first of all, but second of all it's blockchain, and third of all It's YouTube's like requires you to have like this ridiculous approval to even be able to put up links. So like if I'm like, hey guys, download here, like I can't put an annotation over here and like have it download. So I'm about Twitch life, like we can put them in the descriptions and stuff. I'm about DTube and DLive, so we're gonna be integrating that soon. I just need to set up the streams to start pushing that. But we are on Periscope now, and then I'll work to do the other ones. And then eventually what we're going to do is use that live streaming server that I built out in conjunction with Amazon. What was that called, Eric?
Oh, yeah. What is that called? Elemental.
The Elemental, yeah. We're going to start doing some cool Elemental stuff, get the video quality up, and have basically a server that's dedicated to pushing these things out. Very simultaneously, like with better hashtags, not with that little restream thing below. So eventually when we build out the APIs and everything like that, we're going to have pretty cool integration. And we're working on a new site for ForkedBlock right now, which is going to be pretty cool and allow for a little bit more interactivity from the user perspective. By the way, you guys can message in the comments and I'll be monitoring them throughout the stream. But Eric, with that being said, man, if anybody has anything else, you can tag it along. But what do you got for us?
What do I got? Let's just literally go from the top. Can you see my screen?
Yeah.
Yes.
Okay.
It's all yeah.
Let's see. Let's just go from the top. We're gonna just say let's make a new directory for block coding, and we're just gonna start from the top. We're gonna make a whole blockchain. It's gonna be written in Ruby.
I'm gonna cut out my video for a second just so everybody can see what you're doing.
Cool. I feel like my headphones inside my ear really deep, and I think I'm scared.
Oh my god.
All right, here we go. So let's see. This is like my name. Hello.
Hello.
Hey, blockchain. Ruby. All right. So,
Oh,
what's up?
why'd you get rid of that?
You know, because I was like, what's a comment?
Oh,
in
I see.
Ruby?
I
There
see.
you go.
I was just thinking that. Okay.
I was like that. I was like, sometimes because I do these in so many languages, I'm like, is this actually a comment?
The colors looks cool, but that's all right.
Yeah. All right. So at the beginning of like, let's just start from the top. Like, we're gonna import our libraries that are. Let's see. I think that really the SHA-256 algorithm is what we're going to be using for, kind of like faking, not even faking, just like actually putting all of our transactions and all of our information into a algorithm, a SHA-256 library. We'll see what else we do. We want to output it. All the transactions. So a lot of things that I ask people when I'm asking, like, hey, what is a blockchain? Everyone has like a million different answers, but really there's only a couple things that really make up a blockchain. Adam, what do you think is in a blockchain from your top of your memory?
Well, definitely different like intervals of settlement, if that makes sense.
Intervals of settlement.
Yeah.
Okay. So we'll call that like transactions, right?
Yep. You definitely have, verification of the data through cryptography.
All right. So we're gonna call it hashing.
Mm-hmm.
We're gonna call it hash.
A unit of account. You got to have something kind of thing to send from point A to point B. So like a token or a coin of some kind.
Yeah. Okay. Yeah. So when we think about a blockchain, I'm thinking about how do we define what a blockchain is? I'm like, basically, if we just think about a whole bunch of blocks, in a chain, really what that means is that we are referencing the very end of the last block. Because, like, to my recollection, we talk about the genesis block of Bitcoin or any type of blockchain for that matter should have, because of its cryptographic hash, a reference to the last one, and all the way back from where we started all the way to the beginning should be one continuous hash that can't be broken. So that's like the big win there, is that now we have a way to prove if anything's been altered from the beginning to the
A
end. So
ledger. You're saying a ledger.
yeah, the
Yeah.
chain. So like in terms of the chain, I like to know like how many there are, and that's like your index. Another huge part of it is the timestamp, because timestamp really makes it interesting because it introduces the idea of a nonce. Do you guys know what a nonce is?
Yeah, it's what's solved for.
Andrea, a nonce? Any of this nonsense, But basically, what I was saying before, the transaction that happened before is the previous hash.
Mm-hmm. And so basically what you're doing right now, it looks like you're outlining like the data that you're going to be passing on, some of the key components that need to be contained in each block so that you can establish a blockchain. Is that right?
Yeah, because I've been literally writing a blockchain in Python, C++. So I'm like, what do we do every time? We try to define exactly what a blockchain is. And what we're going to do is, even talking in Ruby, we're going to be writing methods as well. So now we have the top of it. We want to have the ability to create and instantiate or initialize the function of, so we'll just call that like initialize. I'll make this a function too. And let's see. We'll make another function for computing the hash, because basically we have to have something to store that, something to create the actual hash, whether it be the previous one or the current hash. Let's see. We're going to do, since we're talking about time, we want to do a calculate a hash with nonce.
Wasn't there something you imported for time?
That was for the last one. The last time we in Python, I believe we used date time.
So with Ruby, is there no import?
I think with Ruby that we don't have to. We don't. I think time comes with it.
Okay.
If not, then we'll have. I have to go through it. I think I think we can just call time.
Okay.
Directly from Ruby. Python doesn't have that imported natively, I think.
Huh.
Computing hash. We're also going to implement proof of work. Calculate the hash with nonce, because we really want to have. We need to derive the header of the block. Somewhere. And something that we want to talk about is the genesis block. Basically create it. So this is like basically the first. And really what we're doing when we're generating a blockchain, what we're doing is the next block. That's basically it. And then we can actually start creating the blockchain transactions, and then print the blockchain out nicely on the terminal. So this is like basically a quick overview of what I'm going to do. And it's really not even that involved. You know, I think the only thing that's really interesting about this is the SHA-256 algorithm that we're going to.
Yeah.
But that's what's important to see is like we're going to break down the mystic aspect of.
The mystic aspect.
Oh yeah, it's like no longer mystic. It's like, oh, that's all blockchain is. I'm like, yes. You know, it's no longer mystic. In fact, you know, instead of shrouding it, you know, it'd be like ERC 2020. You know, like all these different things that could, you know, really just get in the way. We're gonna say acquire, and I believe I have it up over here. It's called digest. This is a core Ruby function. It has a bunch of
That's
methods in it.
cool.
Yeah, so this is basically we're going to instantiate a SHA. It's a instantiate a SHA-256 method from digest itself. That's why you get the semicolon.
There's a method called bubble babble.
Yes. Yes, I think you. Yeah, let's see, bubble babble. Yeah, bubble babble.
What does that do?
Let's check it out.
Returns an encoded version of a given string.
Yeah. Okay.
Okay.
If you can pull that up and let's see. Yeah, we also got SHA-1 base class HMAC MD5 random. This is the namespaces that are shared inside of digest, which is cool.
Okay.
So now we can just bring that back. Let's see. Yeah, so we're just going to say required digest. And something that we used for the other library for Python is PrettyPrint.
Yes.
PrettyPrint's just cross, and they just PrettyPrint's part of it. It just looks nicer.
Mm-hmm.
Ooh, it has the text highlighting. I forgot it has that.
Oh.
Neat. Is this big enough for you guys?
Yeah, it's pretty good.
All right, cool. We're going to initialize the function. Would you like to initialize with me?
Initializing.
Yeah.
Initialize.
Arnold Schwarzenegger hacking code, huh?
Yes, it is. Okay, so we're going to create and initialize the block. Let's see, class. Is this big enough for you guys?
Yeah, it's pretty good.
Class. Block. And we're just going to set up really everything that we just had. So index, timestamp, transaction. We'll just call it data. Data.
Let's play a little bit of music. I forgot to do that.
Why, you don't like the soothing sound of my keystroke? My ASMR voice?
Oh, jeez.
ASMR coding with Eric. What's up?
It's like Bob Ross, except for not at all.
It's like Bob Ross, but way more.
Gotta find the right volume level. So basically we're just talking about block headers right now. That's like exactly where we're going with this, correct?
Well, this is the creation of that block header. So in Ruby, we'll just be like, does it irk you that I use tab and not double space?
No, tab's better. Did you ever watch Silicon Valley?
Some people gets irked. They get way too irked for that, and I was like, oh, I should do this live. Get mad irked.
According to Silicon Valley, tabs take up less memory space. You're writing your code, so it's better to use a tab. I don't know.
We're not working with like kilobytes. You know, we're not working like that. You know.
I mean, if you're a true engineer.
True. I'm definitely not a true engineer. I don't know what I am.
You're a hacker. I'm a growth hacker. You're a hacker.
I'm like a growth hacking. Just sounds like you guys are working out a lot and you're using hormones. Growth hacking.
Yeah, dude. There's different types of hackers, man. There's like they're just different, you know? I don't know what to say. It's like a whole
Hack actually means build.
So, see, what I'm doing here is that I'm just using the actual pseudocode that I have here and just literally typing it up. So this is all done. Now we want to compute the hash with the proof of work. I don't want all this spacing. So we're going to let's initialize. Fine. Initialize. Coding is so fun. All right. So really, I want to be able to, when I create the actual block, I don't need to bring in time because I'll just call it. We need to have the, let's initialize it with index, some data, and the previous hash. Does that make sense to y'all?
Yes.
yeah.
Great.
So what are some like serious like applications for blockchain? Let's be realistic about it, because everybody wants to tokenize everything, and tokenize the world makes sense for like, I guess like a replacement of stocks. Tokens really make sense, but like,
More or less.
like funding is a good application for it. But like, what else? I guess outside of
Security.
yeah. Well, I mean, everything's kind of encrypted, right? And like security is like important, but I guess what I'm trying to say is like, when should you not use a blockchain, right, Eric? Like when is like,
when should you not use the blockchain? Probably most of the time.
yeah.
Yeah, usually when you're using a blockchain, you're doing it wrong.
Yeah.
And you shouldn't. But that being said, I think that when you actually already have a business and you would like to accept cryptocurrency or create your own cryptocurrency for your own internal purposes,
Yeah.
then yeah, that's what it's all about.
So like,
If someone's just like slap a word, like, you know, when Uber came out, it was such a good idea. They're like, yo, we're gonna have the Uber of hamburgers, you know, and then, you know, like, and then
yeah, the Facebook of Twitter, the Twitter of Facebook, the Instagram of Periscope. That's like everybody's pitch. It's like, we're the Facebook of I don't know, widgets.
I think it goes deeper than just a means of currency.
I think it does too, but I think like losing sight of the fact that like Hal Finney and everybody were working on it specifically for a singular problem, which was the double spend. That was like the primary issue you had working with it. The awesome features like smart contracts are even good too. For something like a will, like where you don't have the interference of like a state body or somebody else that might have a vested interest and you really want to pass money along to somebody else, that makes a lot of sense too. Insurance is another area that, you know, is really strong for blockchain. You know, distributed computing too, depending on what you're using it for, like it could make a lot of sense. There's like a lot of applications that people are solving for, but I think it's important to realize too that, you know, there's a lot of applications where, you know, a centralized database actually isn't harmful. So like just saying decentralization in general isn't really a good pitch for, you know, blockchain. It's like, what else do you bring to the table? And I think like the market more recently started losing, you know, some of its credibility because everybody just assumed that everybody should decentralize everything, which not all the time makes sense. I mean, and I'm the most strong advocate of decentralization here, like ever. But I mean, sometimes it's like, well, I'm trying to serve up a website. Well, does a website have to be permanent, like forever? Or like, you know, is it like, you know, there's different applications for it where I just think that blockchain lends itself particularly well, money being one of them, funding being another. Security is definitely a good issue too. Like, I know Paul Walsh and the MetaCert team have a pretty good like URI verification service called Kryptonite that a lot of decentralized people use, and that makes sense too, because like to have like a TCR where you're voting on the actual, I mean, TCRs are definitely hackable, but like
I don't even know what a TCR is, bro. You have to be able to get back to like what we're talking about. I have no idea what we're talking about.
Token curated registries.
Never heard of that.
We can talk about them sometime.
Excellent. I'm trying to figure out my compute hash with proof of work function here. Basically, what I'm trying to do here is inside of the initialization of a block, when you instantiate it, you receive you inherit both the initialize function and the compute hash with work. Proof of work. Say again? Yeah, so we're doing loop do here. One of my always favorite patterns. That do while.
Do while loops, the best.
God.
Oh, we're doing it. We're doing it right. Doing.
I mean, what's wrong with the do while loop, Eric? Can you enlighten? No.
I'm
kidding.
We're just not going to get into it right now. But we're talking about some do. We're talking about some do.
Do loops, okay.
Do.
So why is it? What is like? Let's not like I guess talk about so much do while loops in the sense of like why you should use them or why not you should use them. But let's just talk about what they do. So Eric, what is a do while loop and why is it important in this instance?
Well, basically, it creates a address in memory for every recursive step, and it checks against the table to make sure that a certain Boolean value has returned. And so in this case, this one doesn't really have a lot else going for it, except for a very small conditional. And really, what do they do and why they do it is that they kind of mutate state.
What is that? I've never seen that before.
Nonce? Okay, that's what we were talking about earlier.
Yeah, actually, I was asking about that because the word nonce means number used once.
Okay.
It's so when you're
take a look. Is that we have a blockchain, right? And we really care about its timestamp.
True.
So we have time.now. That means at every moment, no matter what you do, time.now is unique. So every time we know that it's a number used once, that we can never create another block, even though of this, the same identity, because even if it had the same transaction, the number would
not drop. Yeah. Okay.
So and I think that's something else that I want to talk about is that what exactly are we doing when we talk about computing a hash? Really, all we do is that we're going to take index, timestamp, the data that we're using, the previous hash, and we're literally going to be turning them all into a string and pushing it through the SHA-256 algorithm. So really, no matter what it was, if it's an address or if it's a timestamp or, because I bought some pasta, whatever, turned into a string, and we're sending it off to the SHA-256 algorithm and then returning that. So that's really all this function's doing, is that actually we're passing an integer into here for difficulty.
Okay.
And difficulty, it basically is telling the algorithm how many times to go through. So that's hashing really process. And that's what's interesting about the SHA-256 algorithm, and is that it will actually tell you how many times it was run. So that's what's interesting is that it's a tail feeding into the tail feeding into the input from the output, and the amount of zeros that come off of it is the amount of times that it has been run. So that's how you have the proof work. Do you feel me?
I see. Okay. That's interesting.
Yeah, you can't fake how many times it's happened. So there's a certain amount of computing power that it takes for that particular SHA-256 algorithm that we're using to run. And you have to show and prove that you've done it this many times, and that's what it returns. So really, that's all we're doing here, this do loop.
Okay.
Inside the do.
So you talked a little bit about loops, like in the sense of like I was asking them like why you'd use one, and what I meant by it was like when you're dealing with a do while loop, right? You want something to iterate, right? You want it to continue to monitor and repeat the loop, right? So like while true, execute, right? So can you explain how that's useful in this particular scenario?
I think that I was talking about proof of work, and that's what happens is that, like what I was saying, SHA-256, when you feed the output to the input, you take its argument and pass it back to itself. Really, that shows how many zeros are there, and that if we want it to be difficult for us to have, the change the difficulty rating and make the computer do more work, then we have to have that control. So now we can actually make this do while loop, or this loop do, to iterate as many times as that we give it. So in terms of like, the function compute hash with proof of work, we're putting in a number, and that's going to tell it how many times to chew through that before it spits it back out at the end and back into our block header.
So difficulty equals 0, 0. Could you put like any number?
Put like 1 billion.
But it would just take longer.
Take mad long. It's on a laptop, so we'll do a benchmark and see how long it takes with this, and then go back and we'll adjust the difficulty.
Okay.
We'll do that. Let's see. We'll make a hash with nonce. So now we're going to instantiate just like we did before. There's a digest. Now here's the first time we've used it, and we're going to bring in the SHA-256 algorithm. Cool. Now we can actually access it. So if we look at the update, update takes in a encoded string set. So that's what we're going to do. We're going to take the entirety of our blockchain, which is the index, the timestamp, the data, the nonce, and the hash, and we're going to literally pass it in as one big message, and then that's what's going to be, and then
encrypted
text digest. So it's going to eat that, and we're going to poop it out over here at hex digest, but that's actually what we're going to like return when we call it.
Okay.
So we created it so we can actually use it. Let's see.
And the method, Eric, is the .new, correct?
We're going to use .update.
No, I'm saying actually where the method is located on these actual objects that you're calling, right? Like SHA-256.
It's in the namespace of the function.
Yep.
So you can see it's module, class, and then method.
Sure.
Method.
Yeah, I'm just saying, like, for people that are watching, though, like, might not understand exactly what's going on here. Basically, it's like a function or a black box. You drop something in. If you're familiar with calculus, they always describe it as like a black box, right? You put something in it, and then on the other end, something else comes out, right? And what's going on within there is,
a function.
exactly. It takes data, it manipulates that data, and it has an output. And that's exactly what Eric's saying right now when he's breaking it down. So this update is using a specific hashing algorithm here to pass the message that he was talking about onto the next stage, which is the encryption. So it goes in, it grabs a random variable, encrypts the technology. If you're familiar with, encrypts the message. If you're familiar with like National Treasure, where they had notebook and A equaled F.
Hey, can you keep on talking? I'm gonna use the bathroom. I'll be
Sure.
right back.
A equals F and say like D equaled C and Z equaled X. It's like that to a degree, but much more complicated, much more intricate. It basically takes whatever value you have and manipulates that data into a secondary value, which is basically unbreakable. I think the most recent estimate was like 1.56 billion years to be able to actually crack 256. Wow. Yeah, with all the hashing power in the world. I don't remember what the exact data was, but I read that a little while ago, and I don't even know if that's accurate, but you can figure it out with the calculation power.
So is it randomized, though, when it's setting like A equals whatever? Is it just, does the computer choose a random whatever that we don't know?
Yeah, it chooses some kind of random value and then encrypts it using an encryption method, like a encryption algorithm. What you're solving for with a number only used once is basically when you're doing proof of work, all of these different, which now what we're using in blockchain is ASIC specifically for proof of work. Like script mining ASICs, SHA-256 ASICs. These are all different types of algorithms, right? And these ASICs are called application-specific integrated circuits. They do one thing and one thing only, and that is literally try to solve for the nonce. Once one of them comes back with a nonce, it submits to the blockchain network. The blockchain network validates that that's the exact nonce, and then
I never knew that.
Yeah, it rewards the entire network with the payout, right? So it used to. It's like
Bitcoin energy.
Yeah, that's how actually new Bitcoin is created. So the system has a certain set limit of amount of Bitcoin that you can actually ever mine, and that's how the currency itself is deflationary. Because there can be no more of it, each one is more valuable day by day, so long as the network exists, right? And while these workers are trying to solve for these nonces, basically one of them wins it. And when they win it, they say, "Hey, network, I won it." And the network goes, "Let's check it. Good, it looks good. Let's pay out the block reward, which is the transaction fees and whatever new Bitcoin are about to be generated gets paid out to the miners." Now, this used to be done like kind of in the early days in 2009. You could do it on your laptop with just basic CPU. And as it became more and more difficulty, those zeros that you were asking about a little bit earlier, that 0, 0, or 0, the more zeros you add on to a cryptographic hash, it's the difficulty target increases. So it might be that makes it just every zero increases the difficulty of the network. So when they talk about difficulty retargets, the network sees how much time it took between the one block and the next block, and basically evaluates it and decides whether or not it should retarget, and adjusts it basically to make it standard 10-minute blocks in Bitcoin. It's very intricate. We can get into like a lot more, but we're just continuing on.
So let's get into it. Let's just do it. So basically, one of the things that I really like about Ruby is that everything's an object. So I passed this before over here inside of nonce equals 0. And that's super cool because I can just say, like, okay, since like there's a string method or a string class actually in Ruby, literally we can just be like, I want this number that is an integer right now, which is 0. I want it to convert it to a string, and all I have to do is just say to string. That's it. That's sick. So now nonce is, I didn't change the value of nonce, but now when in representation, its representation right here is a string, which is super awesome.
Yeah. Huh. Trying to wrap my head around that.
So no, so this is a number. We just timestamp. It's a number, but I can talk about it over here and say index dot,
Yeah.
and now it's calling a method inside of the string class.
Yeah.
String.
Okay.
Oh well, into the anything class, and then we're making it a string. And what we're going to do is take all the data, and we're going to concatenate it. And that's what's another thing about Ruby is that the concatenation of strings, I can just add these together, and it won't treat them like a value. It will treat them like a string, which is really spoopy.
Cool.
So we're just going to continue. We're just going to create the nonce, the index, the timestamp, and the actual data that we had.
Everything.
Let's make this a little smaller. Bit. To string plus, and we say we've got the previous hash. It's pretty neat. So yeah, we're just cramming everything. Bringing all the data on the block header and concatenating them all together, passing them as argument of SHA-256. Nice.
Yeah.
And we're going to say, we're going to actually create a hex digest. As you can see over here, hex digest will take that string, bing. In this case, it's our nonce, and it's going to return the actual.
Boy.
Huh?
It's crazy how a computer can do that.
It's amazing.
So amazing. Oh Lord.
Yeah, we're almost done actually. Thanks for everybody who's putting up with my live stream antics.
Nah, it's good. Looks good.
This is not. It's not the ASMR video that you want, but this is the video that you need.
By the way, for sure, anybody that's watching, like, we definitely want to hack on different types of code. So, like, if you have a suggestion or something that you would like to see us work with or build on, or whatever, just submit it up. Like, I'm open to learning new things and playing with some things that anybody else is. Like, I've been researching a lot of different chains out there, and it's interesting some of the things people are working up. Like CryptoGal, you were talking about what was it? Quantum
QRC.
Yeah, QRC. Yeah, that like obviously probably not something we're gonna work with, but very interesting.
I'm curious as to how we could build something with that protocol.
I'd have to research it.
Yeah.
Nice. Well, check this out. This is a very simple function that's just going to create the Genesis block. Really, it's the first time that we use block in a sentence. That's kind of like how I think about it, because we built up this like the grammar. So we're just saying the data, in case nothing is passed to it, we're just going to give it a nice little privately scoped value called Genesis, and we're creating a new block.new, and we're passing 3 data points, which is nothing. 0. It's the first block. In terms of like counting and
Okay.
array indexes. You know, we started 0 a lot. It's kind of like
So
the root of all the off by 1 errors, and we're gonna get there. Let's see. We're just talking about. We're still inside the self. And I think
so
yeah. And I actually created. We created the Genesis block. Very cool. And then we got the next block. Next. And we'll call that. Let's see. We'll just seed it with previous data or previous block, and we'll call this data transactions. Call block.new. And previous is going to be that object passing itself. So we're literally going to talk about, we can use the word hash because we've instantiated it up here. And it's going to get really tiny. So no one can read it.
Why are you doing that?
Oh. Because I'm live.
It reminds me of like that Zoolander thing where he's like, this. They like it's the people, the Institute for People That Can't Read Good. Do you know what I'm talking about? And he's like, what are you talking about? This needs to be at least 50 times its size. It's like it's unacceptable. And it's a model.
Yeah, this is the blockchain. It's that size.
It's that size.
It's a qubit.
Oh, qubit. I like that reference.
Yeah.
Yeah, we're down with physics references, boy. Okay, so.
All right.
It's called Next. All I did was add 1 to it. That's amazing, right? Done.
Just 1.
Just 1.
But does it keep going on?
By the way, if we weren't even live,
as many ad blocks that we had, yeah.
If we weren't even live streaming this, we would just be doing it anyways.
Yeah.
Yeah, I know.
Just because it's awesome.
Yeah. 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 So I just finished that, yeah. Now this is everything.
So like when this is actually being computed, right? Like independently on like one computer, like when does it simultaneously happen? Like on multiple computers?
Oh,
you know what I mean?
Yeah, I know what you mean, and that's what it's like that the whole race to mine the block is that struggle, because actually multiple people create blocks at the same time. But really what happens is the network effect grows, just like a viral tweet. Basically, you have to convince everybody that you got it. So what if someone in Shanghai got it at the same time you over here in Wyoming? Basically, it's going to tally up. Just imagine, mushrooms growing on the globe or something, and it's going to colonize, and then basically the colony that's biggest, or the amount of computers that agree that the computer in Wyoming got it before the computer in Shanghai is bigger, then that's who wins.
Okay.
So, yeah, there's blocks already mined all the time that are happening that happen at the same time, simultaneously.
Crazy.
Yeah, it's really amazing. But like, well, if someone's faster, you're just gonna
lose.
You're just gonna win. That's why they beef up their rigs so they can just beat everybody. So this is one of the more important things. So I instantiated B prime, B0. I instantiated the block. We used its method first. I passed the word Genesis. It could be anything here because it's the first freaking block. Okay, yeah, that's it. The next block, that's what's important. Because remember what I was saying before? The whole idea behind a blockchain is that we're reference the block before it.
Uh-huh.
And we're going to buy spaghetti.
Spaghetti.
Put it in a bag. And then the next one is, let's see. What should we buy? But dark web. Either or all.
No.
I don't even know what.
What are you doing? What are you doing?
Eggs and waffles.
Yeah, eggs and waffles is much more appropriate. What do you even do with an inhaler? Good lord.
Yeah, what the
It's for asthma patients like me.
Yeah, so like, I guess you could do that because like, what if somebody in Venezuela needed like, you know, some medicine or
You can
something?
do whatever you want.
Yeah. Being serious. That's like the coolest application of blockchain for me. That was like why I got involved, really. Like, was reading about essentially like North Korea and then learning simultaneously about blockchain. And I was like, wow, if I was like a border guard and like stop somebody, but they only had North Korean money, like how could I like take a bribe and like put them across? Or like from the opposite perspective, like what if I wanted to pay them? Like you can literally do digital online work and like use this stuff like for like an oppressive state or something like that. You can use it as currency. And like a good example of that is like somewhere like you know, like with a really oppressive government where their currency is not worth anything, like people still live there like normal people, you know what I mean? It's like 100% like need things, and like they have no way to make money, but Bitcoin is a national currency, like, you know, international currency rather. So like, you know, you could literally spend it anywhere. Yeah, it suffers from some high transaction fees and things, but it's like a really important
global
piece of like being part of this world now. It's you can
check this out. Look, guys, I made a blockchain. It's an array.
There you go.
And if you look at this, it's an array. So it's kind of like a square. So we bought some spaghetti, we put it in a bag, and we put it in the second slot here of an array. But in reality, it's referencing the one before it. So we have a blockchain. So not only do we have it in a row, but it's a linked list, an overhyped linked list.
Well, I mean, but like it's the beginnings of something that you could do like a trustless system with, you know, like you don't necessarily just have to say I bought eggs and waffles. Like you can do a lot of things with it. You can do anything you can do with a database.
You could put an IPFS hash and the address to where all your app is in.
Yeah.
Decentralized application.
all right.
You could you could write code within the messages, then encrypt those messages.
You could have a poem. You could have a poem.
Mm-hmm. So like that's part of like what the EVM is. Like they store essentially code on the blockchain and then it uses that code. So that's like what smart contract and Solidity are.
Yeah, that's what's interesting about what Ethereum is. Because
Wow.
now when we talk about what Bitcoin has this data feed, right? Data. I say data.
Data.
But yeah, but
Data.
Bitcoin only has a very small amount of data that you can actually put in there. Don't quote me on this, but we'll just say it's not a very large amount. I can't give the exact number.
There's a limit?
Yeah, well, in Bitcoin.
I mean,
like in Bitcoin, and that's what made Ethereum so powerful, is that what they did is that he Fitz with Buterin and friends added another header here in the block, and it said bytecode.
Oh.
And bytecode, it can be as long as you want it to be. So you can.
There's no limit.
Well, the limit has to do with gas, but technically no, there isn't. he wanted to make a Turing complete language that could read and write anything. So if you had enough gas, then yeah, it could be as much as you want. But the idea is that it's no longer limited by the constraints of Bitcoin, where that's the space. So that's literally what Ethereum is. It's the same thing. It's a block with an index, a timestamp, like some shitty data, the previous hash, the nonce, and the actual hash, and it's pretty much like that's it. But now we can just be like add, an unlimited amount of executable code namespace. Like that's pretty much Rockstar. And when he came out with it, pretty much changed everything, and that's why people trade against Ethereum, because it's not like a Litecoin. Litecoin literally is just a fork of Bitcoin, but faster, lighter.
Yeah.
But Ethereum creates coins. So like, the biggest drama, the biggest drama that comes from creating your own quote unquote mainnet, when like a coin's going to go mainnet, really has to do with the idea is that you have to convince a bunch of people to mine for it. So with Ethereum, since Ethereum's being mined, your coin that you're creating with your Solidity contract is already there. You don't have to convince anybody to start using it. And that's what's so amazing about Ethereum, is that now you can make your own shitcoin.
Oh, I see.
Without having to have a shit ton of hardware.
Yeah, it's different conditions. Yeah.
Mm-hmm.
Yeah.
So, let's just cooking show style come back over here to my other terminal.
And it's done. Yeah.
Oh, jeez.
So yeah, this is essentially the readout.
Like my cooking show style?
Yeah.
It's beautiful.
Yeah, so literally that's what Pretty Print does. It's pretty. It's better than what it would be before. It actually has like some nice like indenting over here. And really it's just like over here we're just saying, hey, we have a block.
Life is crazy. Like, how does this even happen?
How does it even happen? How does this even happen?
Shout out to Hal Finney and Hashcash and all those cryptographic guys that spent hours and hours trying to solve the double spending problem.
Basically,
months.
Thanks to your Unix dad.
Yeah,
open source is super important, everybody. Subscribe that channel for open source software, because there are people who have spent their entire lives so you can have
cool graphics like this.
Cool graphics.
Dude, you know what I can't wait for? When it's like a hologram and you can just like take something out of your screen.
Yeah.
Yeah,
that'd be super sweet.
I mean,
I can't wait.
We are actually what we should do, Eric, seriously, is work with VS Code so other people can just have the code in their terminal while we're working on it. Do you know what I mean?
Yeah, I definitely wanted to use VS Code, but you know what? I think that the Zish shell is pretty sexy, so I'd have it again. It's like there's nothing there. It's just like it just makes you feel like a coder. Like, oh, this is my Zish shell.
Yeah, I'm in the way. Okay, there you go.
Yeah, there's nothing there.
Yeah, and if you join our Discord, and you can see the live streaming thing in the bottom right, we're going to be linking that up to a lot of different platforms, but you should be able to communicate with us on this overlay that I have up. So moving forward, we're going to be coming out with some different types of advances in how we're presenting this code to you. Way too big, Eric. Yeah, so we're going to be coming out with different types of advances that really make it a lot easier for you guys to code with us. So that way, if you want to follow along, you always can. Obviously, these live streams are saved.
Yeah,
and
I want them to call in. Honestly.
Yeah, I mean,
once people start picking up that we're dapping, we dap you up and then dap with our daps,
Yeah, we can. Yeah, it could be like one of those painting shows where they're like, draw a cat, and we draw a cat.
Yeah. Coin that's named Fart.
Yeah. No. No.
Too far.
All right.
Dad's drunk, guys.
Dad is not
Yeah.
drunk.
I'm kidding.
All right.
All right. Well,
I'm
so
about to go. You know, I'm super thirsty after all that talking. I'm about to go drink another.
Bitcoin energy.
yeah, dude, shout out everybody who's in, you know, literally the crypto sphere, as you would call it, I guess. Definitely go and support businesses that are like
flat Earth.
Yeah, crypto flat Earth. Go,
I love it.
yeah, check out Liquid Assets. They are an energy drink that is really embracing decentralization and trying to incorporate, you know, a lot of cool things with what they're doing. There's a lot of talk. I don't know how much I can say about them, but they want.
It's healthy.
Yeah, I mean,
It better be. I've been drinking I literally slammed 100 of them. So if I die,
it's a little late at night for me to drink another one, but it's
not for me. I'm ready.
yeah, I mean, we'll probably be up coding for a couple more.
Yeah, that or like everybody else on the team play Fortnite.
Yeah, I mean, we should do a Fortnite stream. Honestly, I'm cool with it.
I want to know the thing is, my fantasy is that we have Fortnite going at the same time. Because sometimes you got to get sweaty while you're coding.
What?
I'm not a big fan of Fortnite. I like Halo 4. I like Black Ops.
Okay, well then you can live stream with someone else.
yeah. Yeah. So, I mean, that's how you build a blockchain in Ruby, I guess, is the summation of it. And I mean,
proof of work.
Yeah, with proof of work. So, like, if anybody has any ideas,
this is kind of like my own proof. Like a video is like my own proof. Like, yeah, I did it.
Yeah,
it's on the internet right now.
Yeah,
proof.
Yeah, we do.
Proof of live stream.
Proof of live stream.
It's there forever.
Yeah, let's just invent a bunch of proofs. Proof of computer screen. Proof of
heart palpitation.
Proof of
what?
Intergalactic planetary. Yeah, so I guess the summation is if anybody's watching wants to keep following us, we're going to be coming out with a lot of different content. We've been putting a lot of work into the GitHub. If you check it out, it's just github.com/ForkedBlock is the username. And you can check out that repo. And, there's a lot of different projects on there that are really cool. A lot of them come from people that have been developing because it's all open source based. And then we just put some twist on it. I know John May is working on 99 bottles of beer, which is a really cool little dApp.
Yeah, we're working on so you can pass the token around.
Yeah, if you
and then it goes away after you pass it 3 times.
Yeah, so there's not enough beer left, so the token evaporates.
Yeah,
Anyways,
I think we're gonna try to do that one in Solidity, and we're gonna do which is the Python compiler for the Ethereum virtual machine.
Yeah, and then also you can follow us on it's like ForkedBlock across the medium, Twitter, Instagram, Facebook.
Yeah, subscribe with that big red button. Smash that subscribe button. Ring those bells.
Ring those bells. And
I actually rang those bells, and I'm subscribed. And when I actually started watching the live stream, it popped up on my phone. I was like, "That's amazing."
Yeah. So definitely, definitely check it out. We're gonna definitely be bringing on some really cool sponsors, and a lot of other people that want us to hack the code. We've been in a lot of discussions. So moving forward,
we're hit that subscribe button.
We're coming out with a schedule, releasing a new site, and we're going to be working with some really cool projects on some very interesting code. I can't promise that it's not always going to break on the live stream because sometimes
I actually promise that it will break.
Yeah, so
we can just go ahead and just say we live in 2018 and nothing works.
Yeah, I don't believe anybody compiles their projects right the first time. Maybe
never.
Maybe Vitalik because he's not human, but even him.
I wonder if one time. I hope he listens to this one day and then we'd love to be a part of your show.
That'd be cool.
That's not how he speaks, but.
Oh my God.
Yo, if Vitalik wants to come on here and just school us, I'm down with it. That'd be sick.
Yeah, if he wants to take me under his wing and just let me soar above the God's castle thing, then
Yeah. So anybody that wants a code hack, anybody that's got something for us that we can work with, if you want to call in and work with us, I know we're talking about doing that with a couple different companies, but definitely interested in working on a lot of different projects because there is a lot of cool technology. We kind of bash on blockchain sometimes because I feel like we're just so deep in it. We're like, oh my God, there's another coin. Why is there another coin? But like, yeah,
why is there another goddamn coin?
No, but like,
no, it's a good question to ask before.
Yeah, it's fair. There's a lot of things about coins that you should definitely evaluate before definitely investing in them. But even devoting the time to hack, definitely just play around with it for a little bit before you go full deep into developing on it, because some of these chains definitely aren't going to last the test of time. There's no doubt in it. I can just reference the .com boom for that. I mean, I think it's 95% of all companies that were founded during the .com boom ended up, they had success for a while, but either got absorbed or just kind of flatlined. And it's very awesome to see so many people taking risks, but I would stand to believe that 80% of the market is going to be dominated by 20% of the coins, and that's just based on the Pareto principle, man. I mean, that's just important. So. Long story short, more
talking about
Hmm?
Pareto optimization.
Maybe we should do live streams on literally
other topics.
I think I'm definitely gonna do one on growth hacking and Modic, literally some wizardry stuff, just to kind of show you how to build campaigns out and be like, oh man, I want to get massive amount of email, or I want a lot of subscribers and stuff. Yeah. As soon as I let them out of the bag, though, some of them, there is some secret sauce involved, because when you have a competitive advantage, you don't necessarily share it. It's not exactly open source, but I'll definitely show people how to build, some bots and stuff, and, maybe how to...
Yeah, we were talking about doing a Twitter bot where, when a person is added to your Twitter, that we can snag their email address. I'm not sure exactly how that works, but we can definitely work. I want to... Huh?
I don't think you can grab their email address.
Can't get it right there.
Well, you can't do it directly. You could do some AI stuff where you comb the internet and then grab their email address, link their account together. That's kind of creepy, but you probably do it.
That's what I want to do. To be honest.
Yeah, dude, I'm cool with it. I mean, everybody should join. Everybody should subscribe, and definitely check out our links on Eventbrite. We have a huge one coming up in San Francisco in January. That one's going to be bomb. We already have a ton of subscriptions for it, which is great. I know Raleigh's got a bunch on Meetup and a bunch on Eventbrite, but if you check out our Eventbrite,
Raleigh's going to be pretty beast mode. I was thinking about it. I was like, oh man, we started one in Raleigh. I wasn't sure if it would be super great, but actually looking over the figures, there's 40 people showing up, and I was like, oh, if we can get 40 people in the room to hack on anything,
yeah,
amazing.
And we'll definitely broadcast our stuff live from there too. I mean, I got a decent camera, and by decent I mean it works for live streaming. And we're gonna set it up, and we're gonna try and get the audio and video quality a lot better, and maybe some interactive stuff. I don't know how we're gonna do it. Maybe we join on a Discord call and kind of show you guys where we're at during the hack.
I think that we're gonna try to hang on Discord. Just because you can't do that, what are you going to do it on Slack? Get out of here.
Well, Google Meetup. So here's the other thing too. We could maybe do when we have a big event. On a big event, if we had Meetup or a Zoom where everybody had their screens and we could pop in and out and stuff and a camera angles.
Zoom sucks.
Yeah, but it does a lot of calls at once. I don't know. We're gonna have to work out the tech on that side of things. That's okay. That's not that hard though.
We figure it out.
Yeah, I mean, we can definitely do some minimum stuff, some good motion graphics, some original music.
Yeah, I was gonna live stream making the beat.
Yeah, dude. So we're making an intro beat, and we're making some. We're making some, overlays for the beginning, and then we have some cool interviews lined up. It's just a matter of putting them on the calendar and doing the calls, and that should be fun too. And we're gonna try and not keep it oh, well, how much do you think your coin's gonna be worth, or how much this? No, we're gonna talk about we're literally gonna talk about some boring tech stuff for sure for some people, but then we're gonna
make it super boring. I'm gonna get so dry that like
No.
I turn into a ramen packet of.
No, we're gonna find a good. It's gonna be value entertainment, value and entertainment. We're not gonna go super Eric dry. That's not gonna happen.
Oh yeah, it is. It's gonna be like some dry rum, like powder sprinkled on top.
Yeah.
We
Just
might
gonna chew it up.
and yeah. So,
If
anyways,
you guys never done that, then you never been.
Yeah.
Just hanging out, eating some ramen.
This is probably the best.
About C++.
The best. I think this is the best live stream we've done in terms of audio and everything else, and we'll just get better as we go along. So every time we're learning, and any feedback you got, just put it in the messages. We have a lot of plans to scale.
That'd be great if you could just subscribe, ring those bells, comment, like it.
All right.
And what is it in Twitch? You can hit subscribe button. Was it if you have a Amazon account and you have a Prime account, you can actually subscribe to our channel.
We should do a Who Wants to Be a Millionaire like Bitcoin edition, and just call like the most famous person in Bitcoin and just grill him with questions. Like how much does this guy know?
What do you set your coil at when you vape?
Yeah. Yeah. No, like literally ask them like questions to see if they actually know stuff. Because there's some talk about some people up top that don't know a lot about the tech, which is interesting. So I guess if you got money, you don't necessarily need to, but I'm curious.
Right. You know what I'm gonna do?
What?
Get a cheesesteak and drink some Bitcoin energy.
Yeah. Okay.
So
all right.
This is me signing off.
I'm gonna end this. I'm gonna end this stream, and
Arrow.
I'm gonna do a roll in, and we're gonna be out. So I'll see everybody later. Talk to you.